Bigger on the bottom.
No, you're fine. Okay, so this is a Bobo. Very good. Because where is the x bigger? On the bottom. Okay, so that means y equals 0. The ends of the graph are going to curve off to 0. Okay, then from there we have to factor. The top of that's not going to factor. 3x plus 5, we're going to leave it alone. But the bottom of that can factor. What will multiply to 2 and add to 3? 1 times 2. Now, if I want to get a negative 3, they both have to be negative, yeah? So I'll use negative 1 and negative 2. Now, remember what we learned. If your first term is only an x squared, those are going to be your answers with x. So it'll be an x minus 1 and an x minus 2. Okay, but that's only if your x squared does not have a number in front. Okay, from there, holes are where the graph crosses out, does it? None. Vertical asymptotes are x's left over on the bottom. Do I have any? Yes. Where are they? There are two answers. X equals 1, x equals 2. And then roots are left over on the top. How many x's left over on the top? Just 1. And if you don't remember how to get it, you just set it equal to 0. So if I set 3x plus 5 equal to 0, my 5 moves over. Now it's a what? Negative 5, and then I put the 3 on the bottom. Yep, so negative 5/3. Now, in order for you to have a slant asymptote, the top has to be 1 bigger than the bottom. Is that the case if it's a Bobo? What, did you say yeah or no? Oh, yeah. Okay, so no slant asymptote. Because top isn't 1 bigger than bottom. Okay. Now, not that you have to find it on this page anyway, but you're going to have to find it later, so just keep that in mind. Okay, then my y-intercept, I plug 0 into the top and the bottom, see what's left over. So I have 3 times 0 is 0, plus 5 is 5. Plug in 0 on bottom. 0 minus 0 plus 2 is 5/2. And remember, if it's a y-intercept, it should be a y equals. Okay? Let's see. We'll do one more off this page. Let's do number 4. And we'll do number 3. Okay, look at number 3. First question. Bigger on top, bigger on bottom.
Bigger on top.
Bottom.
It's a bed C. Look, it's an x squared and an x squared. Number 3.
Uh-huh.
Go through this problem like really slow.
Sure.
Okay.
So the first thing I'm going to look at is my powers. So I notice that x squared and x squared are a match. So that means bed C both equal. Divide coefficients. Remember, coefficients are the numbers that come in front. So that's a 1x squared over a 2x squared. So it's going to be y equals 1/2. Okay, for your holes, vertical asymptotes, and your roots, you have to have it in factored form. So in order to have it in factored form, we need to actually factor it. Yeah? So on the top, we're going to have to do a t-chart. What will multiply to 20? What are my choices? Okay, 1 and 20, 2 and 10, 4 and 5. Okay, all of those are right, but then I need them to add to 9 in the middle. 5 and 4, but I need negative 9. And negative 5, good. So both negatives. Now, remember what I said. That's the answer if your x squared doesn't have a number in front. It's a regular x squared, so I can shortcut x minus 4, x minus 5. Okay, on the bottom, what can I take out of 2x squared minus 50? Okay, GCF, divide by 2.
And then you do,
Very good.
plus or minus 5.
So 2x squared divided by 2, that's going to leave me with just a regular x squared. And then 50 divided by 2 gives me a 25. And then from there, I notice that can break down one more step. Those are both perfect squares. So When I break it down, okay, I'll do it in red right underneath, square root, it's going to be an x plus 5 and an x minus 5. So I'm going to cross out the old version and I'm going to put the new version in instead. So I have my 2 that I pulled out to the front and my square roots were a plus and a minus 5. Now, which of those is going to leave a hole in the graph because it cancels? Very good, the minus 5s. Where will the hole be in the graph? Positive 5. Vertical asymptotes are left in the denominator. What's left in the denominator? Negative 5, because a plus 5 was left over. And then my roots are what's left on top. What's left on top? X equals 4. Then from there, my y-intercept, remember, you plug in x equals 0. Okay, if you want to make a little note, that's how you find the y-intercept. So I'd have 0 minus 9 times 0 plus 20. Well, that just give me 20. And then on bottom, I'd have 0 minus 50. That's negative 50. Okay, yeah, those can both divide by 10. So divide by 10 on top, you get 2. On bottom, you get 5. So y equals negative 2 over 5. Make sense? Because remember, anytime I plug in zeros to these guys, they just end up crossing out. That's why you're basically just picking the number off the top, number off the bottom. Good? Okay, turn the page. We'll do maybe one more. Number 5. Okay, Boba, Bot, and Betsy for the horizontal asymptote. Bottom, very good, because where is it bigger? X3 is bigger, X3 is on top. So remember, bigger on top, N stands for none. That means the ends of my graph aren't curving off to a specific number, they're just going wherever they want. Okay, for the holes, vertical asymptotes, and roots, I have to factor. What can I take out of the top? An x. So I'm going to take an x out. What's going to be left over when I take an x out?
X squared minus 3x minus 4.
Good. Now, look on the bottom. Anything I can take out down there?
Yeah.
Those can both divide by an x as well. Very good. So then from there, I have my x in the front. I have an x minus 4 left over. Bless you. Now, take a look at your little top chunk of numbers here. If I can't break it down further, fine. But if I can, I need to do it. That can go one step further by t-chart. So what will multiply to negative 4 and have a difference of minus 3? 1 times 4. But then if I want to have a minus 3, do I minus the 1 or the 4 side? Minus the 4. Then I look at the front. My x squared doesn't have a number in front. That means I can shortcut. So I'll have x in the front, x plus with a 1, and then minus with a 4. On bottom, I had an x and an x minus 4. Okay, 2 things can cross out. What are my 2 things? Okay, the x minus 4s and the x is in the front. Now, for the x minus 4, where will the hole be? At positive 4. And what about for the x in front? 0. 0. Okay, so I'm going to put a little star here. X in front means x equals 0. Okay, then vertical asymptotes are x's left on the bottom. Was there an x left on the bottom? So none. Roots are x's left on top. Is there an x left on top? X equals negative 1. Because a plus 1 was left over, yeah? Okay, now for my y-intercept, remember, I need to plug in x equals 0. Now, here's something I think someone in this class pointed out. You can go back and plug into the original, or you can go back and plug in here. So think about what's easier, plug it into that or just plug it into x plus 1? That's all that's left. That's going to be easier. Plug in a 0 to that. What is 0 plus 1? Because everybody else died. 0 plus 1 is 1. Okay, then from there, our slant asymptote. is going to be where?
Long version.
We would have to do the long version of long division. And I guess, we don't really have a lot of space to do
It's x
it.
plus 1.
Huh?
I think it's x plus 1.
Oh, is all that's left over? Okay. Okay, I'm going to put long division. You can work it out on a separate sheet of paper, see if it works, but we don't really have space for it. Okay?
Not like a simpler way to do so.
Okay, so in this case, think about if I'm dividing and only one thing is left over on top, that is going to be your slant. But other than that, no, you'd have to do long division. Now, for number 6, when I do long division, would I have a shortcut available? If I'm dividing by x plus 2, what would I put in the box? Minus 2. So for this one, you could do a shortcut if you want. Okay? Alright, last little section. Let's do maybe like number 9 and 10, and then we'll be done. Okay, number 9. I have a hole at x equals 2 in the graph. Where does that go? Top, bottom, or both? We learned this yesterday. Both. And it'll be an x minus 2. Okay, remember that holes need to be in both parts of the equation. Roots, where are roots found? Top or bottom? Top. So if I have x equals negative 5, it should be an x plus 5. Vertical asymptotes, where are those found? Bottom. I have a negative 2, so that's an x plus 2. I have a 3, that's an x minus 3. Okay, then the last thing, my horizontal asymptote is supposed to be 0. That means that it must have been a bobo. And is it bigger on the bottom like we want it to be? Yes, because I count how many x's on the bottom. 1, 2, 3, but only 2 on the top. So bobo, that's a check. Okay? Alright, go to number 10. Horizontal, or hole in the graph at x equals 6 and x equals negative 2. Where do holes go? Top and bottom. So I'll have an x with a minus 6 and an x plus 2 in both places. Okay, remember that holes have to be in both places. Otherwise, they couldn't cancel out, right? Okay, then I want a root at 0. How do I make a root at 0? X in front. Very good. Okay, then for my horizontal asymptote, if I want there to be none, is that a bobo, a botan, or a Betsy? That's a botan. None is a botan. And is it bigger on top like I want it to be? Check. Yes, it is. Okay. And then I don't think we've done one with a double root. Try number 11. Give it a shot, and then we'll check it. See if you remember how to make a double root. Nope. Yes, you do. Okay, where do roots go? Top or bottom? Okay, top. So I have a root at 2, so that'd be x minus 2, right? And then a double root at 5 means I have x minus 5 squared. Okay, that's all you do when it's a double. And remember, what happens at a double root? Your graph has a bounce. Do you remember that? So if you were to graph it, you should see a bounce at 5. Okay, then from there, vertical asymptotes at 0, 1, 3, and negative 10. X in front for the 0. What about the 1? What about the 3? X minus 3. And then what about the minus 10? X plus 10. Bigger on bottom for a y equals 0, and then I check to make sure I have more x's on the bottom. How many x's are on the top? Careful. 3. Because I count this one once, and then I count the double twice. So that's an x3 on top versus how many on the bottom? x4, and 4 is bigger. Okay? Alright, let's see. I feel like the rest of these we can probably do tomorrow. Okay, last one that I pick. We're going to do 13. Okay, 13. I want you to mark your asymptotes. How many asymptotes does number 13 have? 3 total. How many of them are vertical? 1, 2, and then how many are horizontal? 1. Okay, so let's label them. So I have vertical asymptotes, then I have a horizontal asymptote. Okay, so let's count where they are. So here's 0, you can see the little baby x here. And then here's y, you can see the y here. So if I'm counting, this is the origin. This is 1, 2, 3, 4, 5, x equals 5. And then this one is 1, 2, 3, 4, so that's x equals negative 4. Those are my vertical asymptotes. Okay, then I need to count my horizontal asymptote. How high is my horizontal asymptote? 1, 2, 3, 4, 5. So that's y equals 5. And then do you see any roots where it hits the x-axis? Yeah, one here. And then the other one, we're going to have to estimate, let's say that it's 1, 2, 3, 4 and a half. So we'll do my roots down here. X equals 4.5 and 1, 2, 3, negative 3. And then from there, I should be able to write the equation. Okay? So let's look at our graph. What factors should I have on the top? Roots or vertical asymptotes? Roots. So if I have 4.5, that'd be x minus 4.5. And then minus 3 would be x plus 3. On the bottom, what should I put? Where were my vertical asymptotes?
4, negative 4.
Yeah, so I switch it to a, positive 4. And then 5, I switch it to a, minus 5. Then for a horizontal asymptote, that means it needs to be a bed C. Both equal divide coefficient, so if I want it to be 5, that's 5 over what? 1. So I'll put a 5 here and a 1 here. Now also question, are my x's equal on the top and on the bottom? I have an x squared on the top and x squared on the bottom, both equal, divide coefficient, so we're done. Okay? Alright, so we have another day of this tomorrow. Say work through number 13 if you want to. If not, you might have a little bit of homework. But we'll finish the review tomorrow. If you're not on Remind, you're not going to get the answer key. So if you want the code for it, I'll write it up here. But your test is on Friday. Yes, ma'am?
I am not ready for this.
You can be, though. You can be ready. Okay, the code for Remind 101 is something. I have tutoring after school.
I'm looking for like get out of that English and repeat.
Oh. Slightly dramatic. HC3.
Okay, so
You have so much time to fix it,
you
though.
write the code.
There's the Remind if you need it.